Okay, do you see my screen now?
Yes po, ma'am.
Lead lang, maingay lang. Okay. So, let us have now design of the shaft. Okay. So, when we say design of shaft, this would be based on, okay, one, okay, we have the shaft design based on loading, okay, and then the other one, we have the shaft design based on code, okay. So, yun dalawa po yung magiging para natin on how we will be designing the shaft, okay. So, unahin po natin is based on the loading, okay. So, ibig sabihin po nito, the shafts are, we will be considering the loads on the shaft, and based on these loads, okay, we will be evaluating its induced stress, okay, and then you come up with the design stress to come up with your required dimension, okay. So, yun po yung shaft design based on the loading. Then the other one naman po is based on the code. Okay? So based on the code, ibig sabihin po nito, we have po the codes na susundin natin, and also yung kanyang rules, okay, or yung guidelines niya on how to design na siya. Okay? So base po sa code, we have the PSME, okay? PSME code, and then the other one is the ASME code. Okay? Of course, PSME is Philippine Society of Mechanical Engineers, and ASME is American Society of Mechanical Engineers. So these organizations, they have, of course, guidelines, procedures on how you will be designing the shop. So you simply have to follow the guidelines, okay, in order for you to determine the dimension of the shop. Right? So let us have first, okay, designing based on the loading. Okay? So based on loading po, yes, friends,
Excuse po, mahina po yung audio po.
hindi ka naririnig. Super
Marinig
hina.
naman po super hina po.
Okay, so ulitin ko ha. Okay. Narinig yung mga una ko sinabi or hindi rin? Hello?
Hindi po masyado, ma'am.
Ha? Mark?
Hindi rin po masyado, ma'am.
Okay. So, paki-interrupt na lang ako kung hindi pa rin natin. Okay, so let us have, today, we'll have the shaft design. Okay? So, sa shaft design po, we have, yung paraan po natin ang the design of the shaft is, una, is based on the loading. Okay? And pangalawa po ay based on code. Okay? So, this is how we design the shaft. Okay? So, we will consider first po yung based on loading. So, ibig sabihin po nun, titingnan natin what are the loads, okay, that are applied to the shaft. And from there, okay, dun po tayo magkukuha ng induced stress natin to be equated to your design stress. Okay? So, yun po yung unang way natin. The second one naman po is we will have the shaft design based on the code. Okay, so sa code naman po, we have the ASME code, okay, and the PSME code. Okay, so yung pong dalawa na to, meron talaga silang written procedure on how you will be designing the shaft. Okay, so we will be simply following, okay, yun pong na written doon sa code for us to arrive at the required dimensions. Okay, so yun po yung dalawa. Of course, yung po sa code, PSME at ASME. Okay, so PSME po, Philippine Society of Mechanical Engineers. Okay, ang ASME naman po is American Society of Mechanical Engineers. Okay, as to the scope po, of course, yung PSME, that would be valid only sa Philippines. Okay, naman pong ASME, it would be valid, mas ano po, mas madami po yung nagfo-follow doon sa aspect, okay, since ayun po yung standard po natin, standard codes po natin na sinusunod. Okay? So, ayan. So, uunahin po ngayon natin is based on the loading. Okay? So, based on the loading, we have po your torsion. Okay? Pangalawa po is pure bending. Okay, bending. And then the third one po will be combined. Okay, so it will be combined torsion and bending. Okay, so yan po yung doon sa loading natin. So, atin po ngayon i-consider, okay, first, yun po your torsion. Okay, so as a illustration po, schematic diagram. Okay? Yung schematic diagram po natin for a shaft, ito lang po yan. Okay? So, this is a long straight member. Okay? Yan po yung shaft natin. And you'll notice po, doon sa magkabilang dulo, okay, meron po tayo yung X na gano'n. Okay? So, this pertains po to your bearings. Okay, so yun po yung nagre-represent yung bearings natin. So, if the shaft is under pure torsion, okay, so meron ka lang po dito na torque na naka-apply. Okay, so that is how po, yung representation ng ating shaft under pure torsion. So, you have here the torque and then the bearing sa pagkabilang dulo. Okay? Now, when you subject the shaft into pure torsion, okay, we call the induced stress as simply the torsional shear stress. And to design this, katulad lang din po iyan, okay, yung ating members under pure torsion. Okay, so iyan po. Tatandaan lang po natin yung pure torsion natin. So the induced stress now is called your torsional shear stress. And the general equation for it is tau equal to Tc divided by J. Okay? T pertains to the torque. C is a radial distance. So, alin po ulit yung tinatawag natin na radial distance? Kung ito po yung shaft natin, it is always measured from the center. Okay? So, from the center to any distance po, ang tawag po dyan ay C, the radial distance. So, if I want to see, to obtain the C maximum, okay, the C maximum, of course, would be equal to the radius. Okay? So, yun po yung C. And then J po would be the polar moment of inertia. Okay, so we recall J for solid is I d to the fourth divided by 32. And J for hollow is pi quantity d to the fourth minus d to the fourth divided by 32. Okay? The big letter D pertains to the outside diameter and small letter d is the inside diameter. Okay? So, yun po yung ginagamit natin as the value of this J. Again, we call this J as the polar moment of inertia. Okay? Now, so, as apply this to the solid shaft, so ipapalit po natin would be yung J for solid para po dito. Okay? So, ito po yung pi d to the fourth divide 32. And, again, sabi ko nga po, yung C po na iyon, okay, we want the C maximum. So, if this is yung solid shaft natin, again, your C maximum is equal to the radius. And radius is, of course, the diameter divided by 2. Okay? So, substituting all of those, yung T, yung C is D over 2 divided by pi d to the fourth over 32. So, with this, you can cancel out d to the fourth and d. You leave here d cubed. 32 and 2, this is 16. So, therefore, your tau becomes 16t over pi d cubed. Okay? So, this one, okay, this is your induced stress for a solid shaft. Okay? So, ito po yung para doon sa solid shaft. And this is to be equated to your design stress. Okay? Again, ano po yung design stress natin na gagamitin? This can be tau u over fs o kaya naman po tau y divided by factor of safety dependent upon the basis of design. Okay? So, it can be tau u if basis on the ultimate strength, okay, and tau y if basis on the yield strength. Okay? Question? Hello?
Wala pa naman po, ma'am.
Okay. So sabi ko nga po, this is just the same as that we have tackled on members under pure, okay, torsion. Now, as applied naman po doon sa hollow shaft, okay, so kung hollow shaft naman po tayo, okay, so ito po yung center. So again, we'll have yung C value, okay. Ano po yung C? So measured from the center, ang kinukuha po natin would be yung maximum. Since C is any radial distance. So halimbawa, pamula po dito hanggang dito, that is also C, okay. Ito, hanggang doon, okay, that would also be a value of C. So, ito po yung tatawagin natin as C maximum from the center hanggang doon. Okay? So, if you are to obtain yung C maximum, then that would be the outer radius. Okay? That's the outer radius. So, when you say outer radius, that's diameter, outer diameter divided by 2. For the small diameter or for the inner diameter, we use a small letter. Okay? So, yung tipo dito, okay, again, the equation, the general equation, tau is equal to TC divided by J. And J for hollow would be equal to pi quantity d to the fourth minus d to the fourth divided by 32. This is 4. Sorry. Okay? So, ito po yung pinalit natin, J for hollow. And then for C naman po, that would be the outer diameter divided by 2. Okay? So, here po, kung isi-simplify po natin yan, it's simply 2 and 32 that can be cancelled. This can be 16. Ito po, hindi po natin makakancel ngayon. Okay? So, we come up with tau equal to 16 TD over pi quantity d to the fourth minus d to the fourth. This is your tau for this is tau for the hollow shaft. Okay? So, ari po yung para sa hollow. Okay? Now, we will be introducing now your diameter ratio. We have there K is equal to D over D. Again, the small letter D pertains to the inner diameter. Okay? And the big letter D is the outside. Okay? Diameter. Okay? Now, so, isasama po natin itong K na ito, introduce natin sa equation. So, ang kukunin po natin would be the equation for the hollow shaft. Okay? So, you have here the equation 16 TD over pi quantity d to the fourth minus d to the fourth. Okay? Ano po ang ginawa natin? We simply multiply po yung kanyang denominator by d to the fourth over d to the fourth. This is simply equal to 1. Diba? D to the fourth over d to the fourth is 1. So, ibig sabihin po, kahit i-multiply natin ito, it will not affect the value. Tama nga ba? Hello? Tama po ba?
Yes po, ma'am.
Okay? So, baka kasi sabihin nyo, bakit po diyan lang sa denominator natin ilagay? Bakit hindi din doon sa numerator? Okay? But then, sabi niya, kahit po dyan lang natin siya ilagay, the value is equal to 1, so it will not affect po the entire value po nitong ating equation. Okay? So, if you multiply this by d to the fourth over d to the fourth, ano po yung nangyayari? Okay? So, the numerator is still the same, 16 pt. Okay? And then you have there pi. Ito po, i-multiply po natin dito, tapos po dito. Okay? So, this will become d to the 8th over d to the 4th. Dito naman po, d to the 4th, d to the 4th over d to the 4th. So, inano lang po natin siya dyan. Okay? So, we have here now, d to the 8th over d to the 4th. Okay? Ang ginawa po dito, ilalabas po natin dito sa denominator yung d to the 4th. Okay? So, ang magtitira na lang po dito would be d raised to the 4th at dito would be small letter d raised to the 4th. Okay? Yan. So, when you have it now, okay, pwede na po natin ngayon i-cancel ito at saka iyan. We'll have here now d cube. Okay? So, magiging d cube na lang po yun. Tapos ito, mawawala na po ito dito. Okay? And, you look at this one po. D to the 4th over d to the 4th is 1. Minus, you have your d over d. Okay? And what is d over d? That is your diameter ratio K. So, you have your 1 minus K raised to the fourth, since both are raised to the fourth. Okay? So the final form would be tau of hollow would be equal to 16 t over pi d cubed times 1 minus k raised to the fourth. Okay? Nasundan po ba? Hello?
Yes po, ma'am.
Okay? And you look at this part po. Okay? 16t over pi d cubed. Di po ba, this is tau of your solid. Okay? Sorry yung sa solid. 16t over pi d cubed. I-multiply mo lang po siya ng, should be 1 over 1 minus k to the fourth. Okay? Yan. So, this one po, this is called your hollow factor. Okay, so ibig sabihin, if the shaft is hollow, it is the same equation lang po doon sa solid, i-multiply lang po natin yung hollow factor. Okay, so yun po yung ibig sabihin. Okay, so ibig sabihin, your tau for hollow would be equal to tau of solid, okay, multiply by the hollow factor 1 over 1 minus k to the fourth. Okay, so this would be 16t over pi d cubed times 1 over 1 minus k to the fourth equal to your tau of hollow. At yan po ang equate natin to your design stress. Okay? So, balik na po ulit tayo dun sa normal design stress natin. Tau U over Fs or tau Y over factor of safety. Okay? So, ang same lang po ito doon sa members under pure torsion. In-introduce lang po natin dito itong hollow factor. So, anong ibig sabihin? Kapag siya solid, so, mawawala ito. Okay? Mawawala lang yan. Idadagdag mo lang siya kung siya ay hollow. But then you have there the same equation. Okay? So, yan po ay base dun sa induced stress. Now, base naman po dun sa atin na deformation failure, okay, we have the angle of rest theta equal to TL over JG. Okay? So, just like po yung ginawa natin dati, okay, yung J for solid, ipapalit lang po dito, okay, pi d to the fourth over 32. Okay? At we come up with 32 TL over pi d to the fourth G. This is G. Okay? And then for hollow, okay, so solid, it would be 32 TL over pi d to the fourth G. G being your modulus of rigidity. So, kung siya ay hollow, ano po magiging equation? It would be theta of solid times the hollow factor, 1 over 1 minus k to the 5. Okay? So, ano ibig sabihin ng ating equation kapag siya ay hollow? It would be equal to 32 TL over pi d to the fourth G times 1 over 1 minus k to the fourth. Okay? So, mas madali po siyang tandaan ngayon kasi same equation lang siya. Okay? You need to multiply it lang po by this factor kung siya ay hollow. But then both, yung basic po niya, same equation. Okay? Ano? So, here, we have po our dimension base sa strength failure at base sa deformation failure. Okay? Again, you will be choosing whichever is higher in value. Okay? Question? Wala?
Wala pa naman po.
Okay. So, ito naman pong pangalawa is when the shaft is under pure bending. Okay? So, ito naman po, halos katulad naman po ng ating pure bending. Ano lang po yung representation niya? Again, this would be your shaft. Okay? And then yung dalawa na yon, sabi ko nga po, these are bearings. Okay? Yung bearings po na yan, para yun yung magsisilbi po kung doon sa ating na bending, siya yung magsisilbi as the support. Okay? So, there would be corresponding reactions on this bearing. Okay? So, if this is point A, this is point B, this is point C. So, we have here reaction at A or force at A and reaction at C. So, parang yun yung naging ano natin, support reactions. Okay, yun yung counterpart niya. And then, paano po ba malalaman mo na merong bending yung shaft? Okay? If you have there yung atin, if you see there is a gear or a pulley, okay, loaded to your shaft, okay, then that serves as the bending load. Okay? Again, if there is a gear or a pulley loaded to your shaft, then that contributes to the bending load. Okay? So, ito po yun. May give, may pull or pulley dito. So, yun po mismo, yun yung mag-serve as the bending load of the shaft. Okay? So, in this case now po, alin po yung mga kino-consider natin na forces? The force that are acting perpendicular to your beam. Okay? So, doon po sa bearings, we have RA and RC. And due to the gear or the pulley, we have here the bending load FB. Okay? So, yan po yung magiging bending loads natin. And from there, mag-solve po tayo ng ating na flexural stress. Okay? So, the flexural stress, the general equation is MC divided by I. Okay? Again, M pertains to the maximum moment. Okay? Yung C would be the distance, okay, perpendicular distance from neutral axis to outermost fiber, and I would be the moment of inertia. Okay? Ngayon lang po, anong pinagkaiba niya doon sa pure bending natin? Okay? Here, we will be considering po a circular cross-section since yung shaft po natin is mainly a circular cross-section. So, it's either lang po solid o kaya po ay hollow. Okay? So, ayan. So, yun po yung ipapalit natin doon sa C at saka sa I na yun. Not unlike dati na meron pa tayong regular cross-section at saka po yung economic section. So, dito ngayon, naka-specify na po siya as circular, solid, o kaya ay hollow. Okay? So, yun po yung ipapalit natin doon. Now, so katulad po nito, so, alin po yung C? So, kukunin po natin yung neutral axis. Okay? So, di po ba ito yung kanyang neutral axis? C would be the perpendicular distance from the neutral axis to outermost. So, in this case, ito po yung ating value ng C. Okay? And what is C? It is simply the diameter divided by 2 if it is a solid shaft. Okay? So, C is equal to D over 2, that is the radius. And yung I naman po, kapag circular, is pi d to the 4th divide 64. Okay? So, coming from that po, yung flexural, which is MC divided by I, altan po natin, M. Yung C po would be D over 2, and I would be pi d to the 4th divided by 64. So, in that case, again, po, cancel out d to the fourth and d. So this is d cubed. Okay, 2 and 64, this becomes 32. So simplifying that, will arrive at 32m over pi d cubed. That would be your flexural stress. This again, this one is for a solid shaft. Okay, so instead of gamitin mo is MC over I, okay, pwede po, diretso ka na dito. Okay, 32m over pi d cubed. Yan po ay kapag solid. Okay? Kung siya po ay hollow, ano po ang ating ina-expect? Okay? Katulad mo po kanina doon sa torsion, we simply multiply that by the hollow factor. So if it is a hollow shaft, we say flexural stress of a hollow shaft would be flexural stress para ng solid multiplied by 1 over 1 minus k to the 4th. Okay? So this would be equal to 32m over pi d cubed times 1 over 1 minus k to the 4th. Okay? That would be your tau f of a hollow shaft. Okay? So, minumultiply po lang natin yung factor na to. 1 over 1 minus k to the 4th. Okay? So, ano naman po, you can see here the derivation po. Okay? Kung paano po natin siya dinerive. Okay? Katulad lang din yung kanina. Okay? You have here the value of C, you have here the value of I, And then, minultiply po natin ang d to the fourth over d to the fourth. That is why we come up with the hollow factor. Okay? So, same derivation lang din po din kanina doon sa torsion. Okay? So, lagi lang po natin tandaan, if it is hollow, okay, that would be the stress of the solid multiplied by yung factor po na 1 over 1 minus k to the fourth. Okay? So, these two po, okay, again, these are your induced stresses. Yan po yung equate natin to your design stress. Okay? Yung ito po at saka po ito. To be equated to your design stress which can be equal to sigma U over Fs or sigma Y over the factor of safety. Okay? Hello? Nasundan ko?
Yes po, ma'am.
Okay? Ano lang po yung medyo bago sa inyo dito? Okay, ito po una. This bending load, FB. Okay? So sabi ko nga po kanina, to know whether the shaft is under this may bending load, okay? Yan po ay kung may makita ka na gear or pulley loaded to it, katulad po nito. May gear po siya doon sa part na yun. So that serves as your bending load. Okay? So, saan ko po makukuha ma'am yung value ng FB, bending load na yun? There are cases that you are given po yung power. Okay? So, from power, you solve for the torque. Okay? So, given power, you solve for the torque. Okay? And then from the torque, this is equal to F times the radius. Okay? Kung ano po yung radius ng gear or ng pulley, yun po yung gagamitin natin dito. At yung force po na yun, that is your bending load FB. Okay? So, ito po yung bending load FB in this case. Okay? And so, force times the radius. So, that gives us the bending load. So, saan po siya manggagaling? Again, from the torque. Okay? Which comes from the power. Okay? So, i-recall niyo po ulit yung mga power formula natin dati. Pinakamalimit po natin gamitin dyan is yung power equal to Pn over 63025. Okay? So, from there, power would be so torque, would be equal to what? 63025 times power divided by N. Okay? In this equation po, ano po yung unit natin ng power? Nire-recall lang po natin ito. Ano po yung unit ng power natin? Dapat i-substitute dito. Hello?
HP po ata.
Okay, correct. That should be in horsepower. Okay, kung gagamitin niyo po yung equation na to, power here should be in HP and M is in RPM, revolutions per minute. Okay? And in that case, yung torque po natin na makukuha dyan would be in pound inch. Okay? So it is in pound inch po. So torque here would be in pound inch. If you consider power natin in HP. Okay? So, dun po manggagaling yung bending load natin. And once you know here the bending load, ano po ang sunod natin gagawin? For you to obtain yung maximum moment. So, anong gagawin natin doon sa bending load? We'll create here a shear and moment diagram and obtain the maximum moment. Okay? So, yun po ang gagawin. So, let us have po sample problems here. Okay? So, unahin muna po natin yung 1. Okay? You try to solve first po yung 1. This is po, okay, under pure torsion. Okay? This is under pure torsion. So, we have your cold finish shaft C1045 to transmit 350 HP at a speed of 700 RPM. Okay? We are given here the diameter ratio K equal to 0.7. So meaning the shaft is hollow. Okay? So you compute for the shaft diameter. When we say you compute for the shaft diameter, if it is hollow, then you are to obtain outside and inside diameters. Okay? So try to solve muna po yung sample problem 1 natin. Okay? Now, I'll send to you po a link for our Jamboard for you to paste your answer po for sample problem 1. So, dito nyo na po i-solve sa inyong solution sa inyo po na mga manual. Then, take a screenshot of it po to be posted sa atin na Jamboard. Okay, saglit lang po. Okay, so you have here now on our chat box yung atin na link, okay? For you to paste your answers doon po sa problem 1. Okay? So, the same lang po yan doon sa dati natin inaral. Okay? We will be using now simply diameter ratio of A. Okay? So, paki-solve nyo muna po yun. Then, we'll proceed with sample 2 for pure venting.